All right, this is a 1996 Lexus LX450, and it's experiencing a lean condition throughout the RPM range. So what we're doing right now is we're doing some test driving, and we're looking at the live data. And what we're looking at right here is this bottom one is our post-CAT O2 sensor, and this is usually a pretty constant trace. It normally looks similar to this, and this is our pre-CAT oxygen sensor, and it will always look similar to this unless you're basically flooring the engine, and then you're going to see both of these come way up, and they should hold relatively consistent because it's a very rich condition. And the reason that you see the rear CAT do that, the rear CAT O2 sensor do that, is because the CAT can only filter out so much. This top one right here, the load value, is the demand on the engine. So think of it that way. So, you know, when you're pulling a hill and you're flooring it, that's going to be the highest load that you're going to see on the engine. So this trace is going to peak up real high. And so now we've kind of covered what we expect to see. So we're going to go ahead and go on a test drive and see where we're at. Okay, so what we would expect to see right here is that both this value and this value should be high, and instead, instead they both kind of bottomed out, which is the lean condition that we're experiencing here. Hey guys, so we just got back from test driving the Lexus, and we're still trying to diagnose that lean condition. So I just wanted to review sort of where we ended up and how we got there and where we started. I grabbed all my notes, so hopefully I don't forget anything. The vehicle came into us with a lean condition. The customer spent some time trying to figure it out himself and was unable to, so he brought it to us. It did come in with check engine light. It was a PO 171, which is a lean condition. There were no other codes though, so we watched the live data, and what we were doing was we were looking at short and long-term fuel trims to try and isolate what part of the RPM range we were going to be looking for the lean condition. And it turned out that the lean condition was throughout the RPM range. So we debated a little bit about whether or not we should do a smoke test, because with a smoke test you're usually looking for a vacuum leak, and we didn't expect to find a vacuum leak since the lean condition wasn't isolated to the lower RPMs, which is what you typically find. However, there's always that one-off, that oddity, so we decided to go ahead and do it so that we didn't miss anything, since it's quick and it's simple and it's definitive. And we didn't find anything. It was expected. So from there, we checked the mass airflow sensor, which in the live data looked like it was okay, but we figured we'd check it anyways. And we did a calculated load test, and that turned out great. However, on a few Subarus, we've seen where the calculated load test reflected a perfect mass airflow sensor, and that ended up being the root cause of the problems. So we kind of developed or learned somehow, or we just implemented doing a secondary check when this condition happens and the mass airflow sensor tests good. And what we do is we apply compressed air to the mass airflow sensor, and then again watch the live data to see kind of how it's moving. And the reason that we do that is to take out an element of computer control. So it's a more manual way of testing the response. So we use a low pressure air nozzle, and we just watch the live data. And again, it's a crude way of doing it, but it is effective. And that, just like the calculated load test, turned out perfect. So from there we did the fuel pressure test, which was also well within spec, nothing to worry about as far as that goes, especially for, you know, a 96, it looked great. And then we also checked the alcohol level, and out here on the Oregon coast we haven't really seen a problem with it, but when we were in the Willamette Valley we did see, not uncommonly, where people would put the E85 in their vehicles and then they would get a lean condition because the alcohol level was too high. The alcohol level in the Lexus was about 10%, so exactly what we expected to find. The only other thing before getting to the injectors is we did check the oxygen sensors, and we saw in the live data that they were responding, and they were responding kind of as expected. But we wanted to make sure that everything was great with them and they weren't causing the problem. So we introduced propane to the system, and we were able to manually command a rich condition just to verify one more time that they were working great, and everything as far as that goes looked perfect. So that leads us to the injectors, and with that I do just want to say it is a 96. It's never had injectors. We don't know how frequently the customer runs any kind of cleaner through their vehicle, and so we have come to the conclusion that the injectors need to be either cleaned or replaced. So that's just kind of a recap how we got from point A to point B, and I apologize if I didn't explain anything well enough, or if I said the wrong thing. I'm not so great at taking the videos, but there you go.